Okay, so today we're going to be figuring out how to find critical points. So critical points are points in a graph where a function's behavior might be changing, like where it peaks, dips, or flattens out. And in calculus, a critical point happens when the derivative of a function is either 0 or defined. Now why does this matter? Because the derivative tells you the slope of the function. So when the slope is 0, the graph is flat. This could mean a min, a max, or just a flat spot, which is called a saddle point. So we run these steps to find the critical point. So the first thing you want to do, you want to take the derivative of the function. So it'll be like, just take the derivative of the function. So it'll be f of x and then f of x. And then that's what will turn into f of x. It's kind of sloppy. And the second thing you want to do, you want to set your equation out to 0 and solve, or find when the derivative doesn't exist. So we can just say it could possibly just equal 0. And then the third one, you want to plug those x values back into the original function, and when you find the full coordinate, essentially. Now, every critical point is a peak or a valley, but there's like no place where turning points could possibly happen. And after finding them, you usually test around this point to see if the function increases or decreases, which helps you find out whether there's a maximum, minimum, or possibly either. So we're gonna have an example. So let's say I want to find the critical points of x to the second minus 4x plus 3. So the first thing is to write that up. You do x to the second minus 4x plus 3. So the first thing I want to do is take the derivative. And if you know anything, you want to bring this down. So this is just going to be 2x. This is going to be minus 4. And because 3 is by itself, that's a constant, which means it's cancelled out. And again, going back to step 2, I'm going to set this equal to 0. And so add this to the side. That's 4, 2x, find that. And then we have x equals 2 as a critical point, but then we also have to add step 3. We want to plug this back into the original function, which is the function that wasn't derived. So then we're just going to do, to erase this first. We're just going to do 2 minus 4, 2 plus 3, and then when we set this all out, it's going to equal 1. So the critical point is 2 minus 1. And then there is a step 4, so we can figure out what kind of critical point it is, and with that we can use the second derivative test. So we want to take the second derivative, which originally we had our derivative for the first function. It was 2x minus 4. However, if we're going to find the second derivative like that, we're just going to be left with 2. And since f prime, so yeah, so then we can just do this, 0. The graph is going to be concave up, which means that the critical point at, let's say, 2, -1 is minimum. And so, yeah, let's do another example. So you can find one for a cubic function. Make our lives a little bit harder. Minus 3x squared plus 2. And then, again, step 1, find the derivative. So this is going to be x squared minus 6x. And again, set the derivative to 0. So then an easier way to do this, honestly, take out the 3x. So that's just going to be 3x, 3x. So, 3x minus 2. And if you set this all equal to 0, like this, you're going to do your x is going to be 0, or x equals 2. And for calculation's sake, I just did this. You just take the opposite. So do this, so that equals 0. Yeah, so that's going to be just positive, and this is just going to be 0. And then we want to plug these back into the original function. And so we do f 0. So let's just do 0 to the third. F to the third minus 3 0 squared plus 2 is 2 and f of 2, which is going to be 2 to the third minus 3 second. That's 2. You get everything out, you're just going to get minus 2. So you have your critical points right here. So your critical points are going to be like 0, 2, and then 2, 2. And then you're going to use the second derivative to classify this. So